Welcome back, dear students. We will continue with question number 6 today. Let's read the question. So here, your question says, the perpendicular bisectors of the sides of a triangle ABC meet at I. Perpendicular bisector. What is the meaning of that? Let's understand. Suppose there is a line. Okay. So there is a line, and if you want to bisect that line, that means if you want to divide that line into two equal halves, you are going to draw a perpendicular, and that perpendicular is called perpendicular bisector. Okay, so all of you know that in a triangle there are three sides. Okay, and when you draw perpendicular bisector of all the three sides, those three perpendicular bisectors intersect at point I. That's what is the meaning of this. We need to prove that IA equals to IB equals to IC. Let's see how to do this. So your diagram looks somewhat like this. Look at this. So this is AB, BC and CA. Now see, this is the perpendicular bisector of AB. So if I call this point X, then since AB is bisected, so that's why AX and XB, they are equal. Similarly, this line is perpendicular bisector of BY. Okay, I'm sorry, BC. That means BY is equals to YC, and similarly we have AZ equals to ZC. Remember, they are perpendicular also. Okay, perpendicular bisector means they are perpendicular also, right? So this is the required diagram for us. Okay, and if you look at this perpendicular bisector, this perpendicular bisector and this perpendicular bisector, all of them meet at this point, and we call this point as point I. Okay, right. So what we need to prove here is, okay, so yeah, I have written the same thing. Okay, that the perpendicular bisectors of AB, BC and CAB, IX, IY and IZ respectively. IX, look at IX. IX is the perpendicular bisector of AB. IY is the perpendicular bisector of BC, and IZ is the perpendicular bisector of AC. That's what is written out here. So then what we observe is AX equals to BX, as I said, BY equals to CY and CZ equals to ZA. Okay, now we need to prove that IA equals to IB equals to IC. That's what we are asked to prove. Let's see how to prove this. Okay, so IA means this line. Okay, this line is IA, this is your IB and this is your IC. Okay, so we will observe these two triangles AIX. Let's look at where is AIX. AIX is this triangle. Okay, so we will look at this triangle and we will look at BIX. Okay, so BIX is this triangle. Okay, so we are looking at this triangle and we are looking at this triangle. Okay, now forget about other triangles, just look at these two. Are they congruent? That's what is our aim. Okay, so here what you can observe is this side and this side, they are equal. This angle and this angle, both of them are equal and both of them are exactly 90 degree, and this side is common to both the triangles, isn't it? So what is happening here? Which criteria should I use? I should use side, angle, side, because the angle is sandwiched in between two sides, isn't it? So it is SAS. So that's why we have C. AX equals to BX, this is given. Angle AXI is equals to angle BXI, which is 90 degree each, as you can see, and one side is common. So that's why we see that using SAS, these two triangles, that is AIX and BIX, they are congruent. Okay, so they are congruent here. Okay, similarly we can show that this triangle and this triangle, they are congruent, and this triangle and this triangle, they are congruent in the same manner. Okay, so what you can do is you can pause the video and note down till here, so that we'll move to the continuation part of this. Okay, so you may pause the video and note down your solution till here. Right, so I was talking about this diagram, all of you know. So by CPCT, okay, so just look at this. As I said, this triangle and this triangle, they are congruent. Okay, so that's why by CPCT, what I can say is this one and this one, they are equal. You know that this one is common. So which one is the leftover side? this part, right? So AI and BI, they are the leftover part, so that's why they also has to be equal by CPCT. So what I have concluded here is IA equals to IB. Okay, similarly we can show that BIY is congruent to CIY. Okay, so you can, I told you, you can show that in the same way this is congruent to this one. So if this happens, then it means that IB will be equals to IC using CPCT. Okay, and call this as equation 2. Now kindly look at this carefully. IA is equals to IB, but this IB is equals to IC, isn't it? So if you combine 1 and 2, from 1 and 2, what I can do is, I can do, see, in fact you need not do this part. Okay, so need not do this part. So combining 1 and 2, what you can say is IA is equals to IB, IA equals to IB is equals to IC, and that's what you need to show in this particular problem, right? So pause the video and complete the solution. Let's move to question number 7. Question 7 says line segment AB is bisected at point P. Understand the situation. Okay, so there's a line segment AB which is bisected at point P. It is not said that it's perpendicular bisector, just you have to draw a midpoint. Okay, midpoint P of line segment AB, and through P another line segment PQ which is perpendicular to AB is drawn. Show that QA is equals to QB. Now your diagram looks somewhat like this. See here, AB is there, AB is the line segment, and P is a point which bisects AB. So I can say that AP and PB, they are equal. Now from P, what you are doing is you are drawing a line which is perpendicular to AB. Okay, so from here you have to draw a perpendicular. So this is perpendicular, as you can see. Okay, and name of the perpendicular is PQ, if you see here. Okay, now what you need to show is, you need to show that QA is equals to QB, QA is equals to QB. That's what we need to show. Okay, so again what we will do is we'll join QA and QB. Okay, so QA and QB, they are joined. Now observe this triangle and this triangle. From the diagram you will be able to say that they are congruent. Using which criteria? Using S angle S, SAS, right? Okay, so let's write down the same thing out here in the solution. Okay, so we need to prove that QA equals to QB. Okay, so we'll observe APQ. APQ means this triangle, and we'll observe BPQ as well. Okay, now from AP we'll take, from this triangle we'll take AP, and from this triangle we'll take PB or BP, because both of them are equal, isn't it? Okay, so they are equal as per the given condition. Okay, now all of you know that this angle and this angle, they are also equal because QP is perpendicular. So both of these angles will be in fact equals to 90 degree. And the last part is PQ, and this PQ is the side which is present in both the triangles, this triangle and this triangle. So that's why I have written common out here. So that's why using SAS we say that these two triangles are congruent. Now see, which part or which side is left? This side is left, isn't it? So that's why using CPCT, what I can say is QA is equals to QB. Alright, so pause the video and note down your solution. Let's move to next question. Next question says, if AP bisects angle BAC, okay, so angle BAC is there, and AP bisects BAC. Okay, so there's a bisector whose name is AP. Okay, now M is any point on AP. Okay, so in that bisector you draw any point M. Prove that the perpendiculars drawn from M to AB and AC are equal. Now what is the meaning of this? Let's try to understand using this diagram. So look at this, BAC is there, okay, and AP is the bisector of this angle BAC. So bisector means this line divides BAC into two equal angles. So that's why there is this sign written. It means that this angle and this angle, they are equal. because AP is the bisector, and exactly on this line AP you are drawing a point M, and from M you have to draw perpendiculars to AB and AC. Okay, and I'm writing MX to be perpendicular to AB and MY to be perpendicular to AC. Okay, right. So what we have done here is MX is perpendicular to AB and MY is perpendicular to AC. Now we need to show that the length of the perpendiculars are equal. That means I need to show that MX is equals to MY. That's what we need to prove. Okay, right. Now we will observe two triangles AMX and AMY. Look at this. AMX is this one, AMY is this one. Now just looking at the diagram, you should be able to see that these two are congruent, but using which quantity? Now you know this angle, this is 90, this is also 90. You know this angle, you know this angle, they are equal, and this side is common. So what is happening here? Look at the sequence: angle, angle, side, right? Angle, angle, side. So we have, as I said, MXA equals to MYA, which is 90 degree each. MAX equals to MAY because AP is the bisector of angle BAC. That is, they are talking about this angle, and one side is common, right? So by using AAS, we can say that this and this triangle, they are congruent. So now what you can do is using obviously CPCT. Okay, so using CPCT, you can see that this side and this side, they are also equal. That is MX equals to MY, and that's what we wanted to show. All right, so pause the video and note down your solution. Okay, so next we have this particular problem. So diagram is already given in the question. So here question says, from the given diagram in which ABCD is a parallelogram. So look at this, ABCD. So this diagram is a parallelogram. Now since they have given us a parallelogram, let's talk about their properties. We can say that AB and DC, they are parallel, and not only parallel but they are equal also. AB is equals to DC or CD. Okay, and similarly AD will be equals to BC. Please remember this. Okay, right. So ABL is a line segment. So look at this, ABL is a line segment. Okay, so it's a straight line, ABL, remember. So straight line means if you calculate this angle, okay, this whole angle, this is 180 degree, I'm sorry. Okay, this is 180 degree because in a straight line, if you measure the angle, it will be 180 degree. Okay, and E is the midpoint of BC. So look at this point E is the midpoint of BC. So if E is the midpoint of BC, obviously BE and EC will be equal. So that's why this sign is given out here. We need to prove that triangle DCE is congruent to triangle LBE. DCE is this triangle, LBE is this triangle. We need to show that this triangle and this triangle, they are congruent. After that, we need to show that AB is equals to BL. Okay, AB is equals to BL. That's what we need to show. And we need to show third one, AL is equals to 2 times DC. Okay, so AL is 2 times DC, double of this DC. That's what we need to show. So let's begin. Now, all of you know, now see, that's what I said. AB will be equals to DC and AD will be equals to BC. That's what I have told you from the properties of parallelogram. All right. Okay, now since ABL is a line segment, since this is also a line, and all of you know AB is parallel to DC and ABL is also a same line, the extended line. So that's why we can say that AL and DC, they are parallel, and at the same time DC will be parallel to BL as well. Simple. If DC is parallel to BL, obviously DC will be parallel to BL also, isn't it? That's what is written out here. Okay, now I've remodified the diagram. Okay, so I have put this sign out here, this sign out here. Now just look at this. Can you see that they are equal? Obviously they are equal because they are forming X kind of figure, and in x we find vertically opposite angles which will be always equal to each other. You have to keep that in mind. Okay, right. So from the diagram you see there's a z kind of figure also, because this one and this one are parallel, so that's why you know this BC acts like transversal. So this angle and this angle, they becomes alternate angles. Okay, so you know that alternate angles are also equal. You need to prove that these two triangles are congruent. This triangle and this triangle are congruent. Now look at this, angle side angle is there. Here also you have angle side angle. So that's why using ASA we can say that these two triangles are congruent. So that's why, so same thing is written out here. Okay, so these two are alternate angles. CE is equals to B because E is the midpoint of BC and they are vertically opposite angles. So you can pause the video and note down till here because we don't have space right now. Okay, so let's continue. So using ASA, as I said, these two triangles are congruent. Simple. Okay, so by CPCT from the diagram, if you look at the diagram from CPCT, we can say that DC is equals to PL. Okay, that is, you now you know in the diagram DC is nothing but AB, isn't it? So that's why AB equals to BL. So I have showed the second part also. Okay, right. Now AL can be written as AB plus BL, isn't it? So that's why, see, in place of, what am I doing is, see here carefully, you know that BL can be written as DC, isn't it? And AB is also equals to DC. So in place of AB I have written DC, and in place of BL also I have written DC. So DC plus DC is 2 times DC. So that's what we need to show here. Okay, so we have completed our all the 3 solutions. So you may pause the video and note down your solution. Today we will be doing our problems till here only. Okay, thank you very much.